Hi, today we're going to be going over rates and units, a kind of small topic that's still nonetheless very important for many types of problems you'll see in Algebra 1 and beyond. They're often interspersed into a variety of types of problems, and they're key if you want to get the problem right. Here I'll show you a basic thing of what I'm talking about. Now, in order to introduce the concept of rates and units, let's start with a common question you may see asked on quizzes or tests or assignments, right? Say I'm driving a car, and I've been going at a constant speed of 50 miles per hour, which you write as mph, or you wanted to write it algebraically, miles per hour, that's miles over hours, right? And I've been doing so for, let's say, 10 hours. How far have I traveled? And so what they're asking is how far. That's a distance question. So they're really asking you, given that I've been going at what we would call a rate of 50 miles every hour, or per hour, and I've been doing that for 10 hours, how long have I traveled? And a great way to represent this, of course, is algebraically. We can say our distance d, is equal to the rate r at which we're traveling, right? How many miles we're traveling every single hour, that's a rate, times the number of hours that we've been traveling, or the total time. And we do that, we'll get our distance, right? So my distance is 50 miles an hour times 10 hours. And you might say, well, hold on. If you look at these units we've attached, how are we going to deal with them in the problem, right? The distance is miles, not miles per hour or hours. We notice something interesting that happens when we're doing this, right? So we have 50 miles per hour. We can write it like that, right? Times 10 hours. Now, as we're multiplying, we're going to get 500 miles times hours over hours. We can actually cancel out the hours on both the numerator and the denominator. So we'll just be left with the miles unit, which is actually what we want. Our distance is in miles. That makes sense for us to think of. And that's kind of the magic of working with rates and units. If you work with them in the right way and you do the right operations, you can transform problems and values that are given in one set of units and another entirely different unit into exactly the unit you want. Today, we're going to go over that. So let's say, what if I was going 50 miles an hour, that my time that I traveled wasn't an hour, it was 30 minutes. How far would I be going? And that's very interesting. I'm gonna write this as I would in my distance equals rate times time formula, right? So, right, where 50 is my rate, 50 miles per hour, and 30 minutes is my time. And I know that my problem is supposed to be, my answer is supposed to be in miles, right? Distance is a mile measure. That's the unit we need. But we're not going to have that, right? This minute unit isn't going to cancel out this hour unit. So what we need to do is do some sort of conversion where we can transform this hour into something that works with minutes. I'll show you how, right? So we can say, if you will, that 1 hour equals 60 minutes, right? Or, that's the real thing that we can do. These are equal. So if I were to write hour over 60 minutes, right? I get 1, because 1 hour is equal to 60 minutes. That makes sense. But if I write it like that, and that's this sort of fraction way, I notice, hey, I'll be able to cancel out these h's. and I'll get something that's only in minutes. And then the even better thing is I'll be able to cancel out those minutes left. We'll see. So I have 50 miles now times 30 minutes over 60 minutes. And sure enough, I can cancel out the minutes now, and I'll be left with an answer that's only in miles. So if I were actually to do the math, that cancels out to 1/2, so I'm left with 25 miles as my final answer. And so we noticed when we were stuck and we realized, okay, I need my distance to be in miles, but if I just multiply, 30 miles per hour by 30 minutes, I'm not going to get miles. We had to do some problem solving, some kind of creative thinking about the relationship between hours and minutes to get our answer. And as you can see, it wasn't really hard. We know that there are 60 minutes in 1 hour. It was just a matter of representing it algebraically. We could convert, this, mismatching unit thing into a mess that nicely resulted in our 25-mile measure, right? And so to do that, anytime you're dealing with conflicting units, try to write them as a fraction, where on one side you'll be able to cancel it out, right? Because this is just one, right? Because hours, 1 hour is 60 minutes, so we're not changing the value or anything. But we'll write it so that one side, in this case, the numerator, cancels out the hours in the denominator and leaves the minutes in the denominator that we can then use to cancel out the minutes in the numerator of this fraction, right? So the real name of the game is working on canceling. How can I cancel units? And this is where you'll really, really, really see a ton of minutes and other related information in a whole variety of problems. Sometimes you'll be, let's say you're doing some sort of quadratic or linear equation problem, and you get your answer, and they'll ask it, and they'll give it to you in units. And sometimes you realize, hey, the units I was working with in the problem are different from the units they want my answer to be in, right? Let's say, for the entire problem, I've been working with feet, right? And then I see at the end of the problem they want the answer to be in inches, right? How do I convert that, right? Well, let's say my answer turned out to be 1.2, let's say, feet, and I want to convert that into inches. So what am I going to do? Well, I know that 12 inches is equal to 1 foot. So if I were to write the fraction 12 inches over 1 foot, it'd be 1, right? Because they equal each other. That means they would be able to cancel out to become 1. So if I were to multiply 1.2 feet by 12 inches over 1 foot, and then it's the interesting phenomenon, I'd be able to cancel out this feet value, right? I treat it like it was a normal equation or a normal variable, a normal value, and I can just cancel it out. And so I'm left with 1.2 times 12 inches, right? And that is my final answer. I can do the multiplication and convert, my value in feet to a final value in inches. But that's not all. Sometimes you need to be careful about what particular unit you're using. And I'll explain that. Let's imagine I'm filling a sandbox, right? It's, a standard sandbox, so it's got, it's a rectangle. Let's say it has, I'll just give metrics. Let's say it has a height of 3 inches and a length of, let's say, 6 inches and a width of, 5 inches. It's a small sandbox. And I'm asked to find, what's the volume, or how many units of sand can I fill the sandbox with, right? And of course, we know that the volume of a rectangular prism is just length times width times height, right? But here's where the interesting thing is. Our answer, the answer to what's the volume of a certain thing, will not be in inches. It'll be in cubic inches, and I'll explain why. So imagine we're taking this all and we're multiplying, right? Well, we can do 3 times 6 times 5. We can also do 3 inches times 6 inches times 5 inches. And we can do the multiplication. We get, 90 inches times inches times inches, right? So we've got all these inches here. But inches times inches times inches, we're multiplying the same thing by itself 3 times. That's the same thing as inches cubed. And so our final answer for volume is inches cubed. So we can say, the volume of this sandbox is 90 inches cubed. This is a very, very important phenomenon. Whenever we're dealing with objects or situations that are in 3 dimensions, right? So like volume, where I'm dealing with, the length and the width, but also the height, I'm going to have whatever unit I'm working with cubed. So I'm going to have inches cubed or feet cubed or, miles cubed if it was possible, or, liters cubed. I'm going to have whatever my dimension is cubed. And if I'm dealing with 2 dimensions, right? Let's say I just wanted to find the area of the base of that sandbox, which is 6 and 5. I could say 6 times 5, but if I think about my units, what I'm really doing is I'm multiplying 6 inches times 5 inches, which is the same thing as 30 inches times inches, or 30 inches squared, right? And that's part of a larger phenomenon wherever I'm dealing with 2 dimensions, like length or width, my unit is always going to be that unit squared, right? So if I'm dealing with 1 dimension, right, or like a simple conversion, it's just going to be, the standard value. If I'm dealing with 2 dimensions, it's going to be my unit squared. If I'm dealing with 3 dimensions, it's going to be my unit cubed. So let's say, we're given, 13 cubic inches. And we're asked to convert that into cubic feet. How many cubic feet is that? We know 12 inches, just inches by itself, is equal to 1 foot. And if I were to actually, do what I did earlier, multiply, 1 foot over 12 inches, right? I get an interesting phenomenon. I would be able to cancel out, the inches here, but what I really be doing is canceling out a single inch out of the 3 inches I'm multiplying together. Right? If I did that, okay, I got rid of 1 inch, but I still have 2 more. I need to do that 2 more times to fully cancel out all the inches. And by doing so, if I were to multiply all these together, you're left with 13 cubic feet, which is what I want, over, what turns out to be 12 cubed, right? So you can see it's not just going to be, 1 foot times 1 foot over 12 inches, right? If it's cubic, or even if it's squared, we need to do that however many times our exponent is, right? If it's cubic, I need to do it 3 times. If it's squared, I need to do it 2 times. It's an important thing to keep in mind, because if you're not careful, it can trip you up. And if you answer in the wrong units, your problem can be marked wrong, and that would be really terrible and disappointing. But with this strategy, you can be confident that you've answered the right units and you've got the problem right. I hope you have a great day, and I'll see you later.